So far we have found the domain and the range of functions that are represented graphically, but now we're going to find the domain and range of functions that are represented as an equation. And so when we do that, we have multiple tools at our disposal that we could use. So one thing we are going to do is kind of look at it and just see what makes sense. So knowing we're not going to delve into the realm of imaginary numbers where we're taking the square root of a negative, what we need to do is look at this and say, well, you know, what x values can I use and which x values can I not use? And so basically, I want this square root, the stuff under the square root, to be 0 or greater. So there are some people that would explain this problem this way. I'm going to show you multiple ways of doing it. So there are a lot of people that would say, well, this thing right here is going to be greater than or equal to 0. So then they would solve it, and they would square both sides. We'd square this, and so x plus 2 is greater than or equal to 0, and then we'd subtract 2 from both sides. And so x would be equal to, greater than or equal to negative 2. And right there, that's our domain. So our domain is everything that is greater than or equal to negative 2. So I'm just going to go ahead and label that as my domain right there. And if you wanted to write it in interval notation, you could say, well, this is everything from negative 2 all the way up to infinity. So negative 2 to infinity, and because I can't include infinity, I will put a parenthesis, but I do include negative 2. So we have our domain represented two different ways. Well, now I've got to figure out what my range is, and we actually just sort of did it. We said, well, this thing has to be greater than or equal to 0, so the output is greater than or equal to 0. So range is all the y values greater than or equal to 0, and we could also say that represented as an interval, it's from 0, including 0, to infinity. And so we have done the first problem without ever really looking at the graph. However, if we wanted to look at the graph, we could. Let me slide it over here where the glare is not so bad. And we can type it in. Now, obviously, I don't have the correct thing typed in, so let's type that in, clear out everything else that's in our way, and then we will just graph it. So I'm going to go to a standard window, zoom 6, puts me on a standard window, which for our purposes will give us pretty much all we need to see. And I look at that and I say, well, which x values am I using? I'm not using any of these x values over here, but I do start using an x value at negative 2, and I move forward to infinity. And then similarly, what y values am I going to use? What outputs am I going to have? Well, from 0 and up. Also, and you have to be careful with this because we can get into fractions and decimals and different things that are between the integers, and we can overlook some answers. But for our purposes for right now, we could go to the table, and assuming our table is listed, well, as a list, then we can start looking at this and saying, well, my x values are from negative 2 and upward because everything else is an error, and my y values, they start at 0 and they move up as well. So, and that's another way of doing it. Now, again, maybe in some problems it wouldn't start at negative 2, it'd be negative 2.5, and it would be harder to really tell from the table. But for this problem, for our purposes right now, that's good. Okay? So let's go to the next problem, and let's do this one with a graph as well. And I'm going to use a calculator. And when I use this calculator, I'm going to run into a few problems if I'm not careful. So square root of x minus 2, and then minus 3. There are some resolution issues sometimes. So standard window. And it's a little bit hard to tell exactly where it starts. You probably could say, well, it starts at positive 2, and I would agree with you because it's the opposite of what's in here, which is a different lesson altogether in terms of translating my graph, moving it around. Nevertheless, you could look at it graphically. You could go to the table like we just did, and we could say, oh, well, you know, this function begins to have valid x values at 2. So 2, 3, 4, 5, 6, 7, 8, yeah. And it has valid y values starting at negative 3 to negative 2, negative 1.58, and it's moving up. So when we write this one, put this where there's not a glare, which is difficult to do. When I write this one, I could say, well, my domain is from 2 to infinity. And I could also say, basically, it's everything greater than or equal to 2. My range is everything from negative 3 and upwards, so negative 3 to infinity. And we could also write that as y greater than or equal to negative 3. Let me point out something here. A lot of times people get in such a habit of dealing with x's and talking about x values, and then when we're dealing with a range, we forget to put the y right here. This is a y. thing. Range is y. You know that, I know that, but we just get in a habit of using x's. Okay, so we can continue with this idea, and we can talk about what the graphs look like and that kind of thing. But on the next one, we're going to not use a calculator. We're not going to use a computer. We're just going to do it, and this is what it's going to be like. So when I look at this, I say, well, what x values can I use? So when I was up here, I said, well, I can't use x values that'll make this thing, this thing under the radical, turn into a negative, because then I couldn't take the square root of it, right? So I knew that wouldn't work. So what I'm going to do here is say, well, what x values can I use? Well, I could plug in anything I want. Like I'm never going to take the square root of a negative. I'm never going to divide by 0. None of that's ever going to happen. Those little illegal things, it's not going to happen. So my domain is going to be all real numbers. Any x value you could think of, you can plug in, you're going to get an answer. And so if you want to write it in interval notation, it'd be negative infinity to infinity. My range also is any output you want. So if I said, man, I want an output of 9, well, done. Plug in a 3, you get a 9. I want an output of 8. Okay, plug in 8/3, you get an 8. I want an output of negative 17. You can do it. Plug in negative 17/3. You'll get your negative 17. So the range is also all real numbers. And I just put an extra L on real, so they're extra real. All real numbers, 1 L in real. And that also goes from negative infinity to infinity. Okay, when we get to number 4, we're going to kind of switch modes here, and we're going to start graphing it. Not on the calculator, but on Desmos, which is a very handy tool for graphing these things. And I will start by finding the domain just by hand. So we can do this one by hand. The domain. What x values can I use? And there are two major questions that go through my mind when I do this. And this is not an all-inclusive list, but when I'm doing these by hand and I'm not graphing them, and this does make it a little bit shorter. I know you're like, well, let's just graph it and see what it looks like. I hear you. That's fine. But I have two questions that run through my mind. Will I square root a negative? And will I divide by 0? And if I can avoid those two things, then for our purposes, for right now, for the types of problems I am giving you in this, then we're going to be good, meaning we're going to have a domain of all real numbers. So I'm never going to square root a negative number. I'm squaring. But I'll never square root a negative number. I'll never divide by 0. This is not even a fraction, and we don't even have any fractions on here other than things that are over an understood 1. So the domain in this case is also all, whoa, wrong color. Not that it matters. That looked awfully Christmassy though. The domain is all real numbers. How many L's does real have? Just 1. All real numbers. And I can represent that as negative infinity to infinity. Any number you want to plug in, any real number you want to plug in, it's going to work. It's going to be fine. My range, on the other hand, is not all real numbers. I will get some outputs, but not other outputs. And so here's what I'm going to do. I'm going to graph this on Desmos. Excellent graphing tool. So I'm going to go to, not there, I'm going to go to desmos.com/calculator, and I'm going to just type that in. So I'm going to type f of x equals, you could type y equals, x squared plus 1. And I look at my graph, and when I look at my graph, I say, oh, well, you know, sure enough, my domain was correct. Any x value I want to plug in will work. So this graph goes forever to the left and forever to the right. Now, I know it goes forever up in both directions, too, but it's always going to the left. I can't see it all, but it's always going to the left, and it's always going to the right, which is why my domain is indeed all real numbers, negative infinity to infinity. My range, on the other hand, I want to know what my y values are, what my outputs are. And so what I often do is I'll just kind of take a horizontal line and I'll run it through here in my head. I'm actually going to do that right now, and I'm going to say like y equals some number. That's not going to work. Y is going to equal 1. Nope, that's not going to work either. Let's make it an A. And then there's an A. It's not going to work. My goodness, I'm having a hard time getting this thing to work. Nevertheless, there's a way you could put a little slider in, and it's not working on this one. That is okay. But here's the deal. I want to know what my outputs are. So I'm going to click on my little red graph here. You see that point right there? That is at 0, 1. So my outputs, my y values, are at 1. So if I did type y equals 1, see that horizontal line that just showed up? I'm going to make this projector mode a little bit bolder. There we go. Y equals 1. And if I was to move this line upward, which I'm having a very difficult time doing. Oh, wait, here we go. There we go, got it. See, as I move my line upward, I'm hitting my graph. But then when I move down here below 1, I'm not hitting my graph. This is what I was aiming for earlier. Now we got it to work. And I think it was user error. And so when I have an output of 1, then sure enough, I've touched the function, the red function. It's working. But when I move it higher, fine. Then I've touched the graph. So those outputs greater than or equal to 1 are valid. So all y values greater than or equal to 1 work. And I'm looking at the y-axis when I say that. My interval notation would be from 1 to infinity. So Desmos is a really good way to help you visualize those things. So we have 6 more we're going to do very quickly, and we're going to use Desmos for them. And so we go to the next one, and we're just going to type it in. It's negative x squared. We'll delete all the other superfluous information. And I'm going to keep this little line floating around here. So I want to know what the domain is. The domain will be the x values that I'm using. And I hope you're kind of looking ahead and you're realizing that, you know what, I'm using all my x values. This thing goes to the left forever. It goes to the right forever. It's forever. Okay? So all my x values are going to be used. So I'm going to slide this thing up and we'll write that down. So my domain is all real numbers, and again that's negative infinity to infinity. My range, on the other hand, is not all real numbers. My range is going to be everything that is, looking at my blue line here, I'm looking to see where my blue line touches the red function, and it happens, boom, right there. And it happens at 0. It happens at y equals 0, and I can look on the y-axis to tell that. Let me turn this off for a second, and you'll kind of see what I'm talking about. This red function exists downward all the way up to and including the y value of 0. So, from 0 downward, this function exists. So I've just determined that the range is everything, every y value that is less than or equal to 0, which means, and a lot of people are going to do this one wrong, so be careful, which means that it goes from negative infinity to 0. It does include 0. Some people would be like 0 to negative infinity. Well, don't count backwards. Don't do that. Okay, let's do the next one. And the next one is absolute value, which really messes a lot of people up. I don't know why, but some people just don't like absolute value. There it is. In case you're wondering where that button was, it is above the enter key. You'll press shift and then above the enter, and then it pops that up. It's also one of the functions you have down here. You could use that right there. See it? Okay, I'm not going to do that. So this is absolute value. Basically, it makes things positive, which means all my outputs will be positive. Every output's going to be positive or 0. So when I'm looking at my range, I'm jumping ahead to range on this one. When I'm looking at my range, then I'm going to say, well, you know what? My range is going to be every y value that's positive, because absolute value makes things positive. So knowing that it makes things positive, then all my y's are going to be everything greater than 0, or it could be 0 itself. If I plugged in a 0, I'd just get 0, right? And look at the graph again. Here we go. See my blue line right there? I'm touching the graph at 0. I'm touching the graph above 0. I'm looking on the y-axis. I don't touch the graph down here. Now, as for my x values, it goes forever to the left. It goes forever to the right. So my domain is all real numbers. And that means it goes, whoops, turn that to a parenthesis, negative infinity to infinity. My range is everything greater than or equal to 0, which means it goes from 0 to infinity. Put them in numerical order. All right, let's do these next 4. Let's go very quickly now. The next one is negative absolute value, which means, okay, absolute value makes things positive, but then I switch the sign of it. Let's take this blue line out of the way. And then when I do that and I look at it and I say, what x values am I using? Well, I'm using all my x's. So it's actually a lot like the one up above it. So my domain is all real numbers, which is negative infinity to infinity. And my range is going to be everything down here. I'm going to point with this little blue line here. Everything from 0 downward is a valid output for my graph. So negative infinity up to and including 0. So I'm going to go ahead and write that. Negative infinity up to and including 0, which really means that all my y values are less than 0, or it could include 0, so it's equal. Okay, for this next one, we still have absolute value. It's still positive now, but we're going to shift it a little bit. We're going to shift it with a negative 2 outside the bars, which means it's going to go down 2, and that's a different lesson altogether. We'll deal with it later. But this is what we have, and you could look at the domain and automatically know what it is, and you'd say, well, you know what? I know what that is. That, my friends, I'm writing it, you can't see it, is going to be all real numbers, negative infinity to infinity. That's my domain. My range, on the other hand, is going to be, okay, let's see what y values I am including in my graph. I'm going to turn this little line back on, and I'm going to just start sliding it around. And as I slide it around, I'm going to say, well, am I touching the red graph? Am I touching the red graph? No, 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 no. Yes, right there. At negative 2, I touch the red graph, and then as I slide upward, I'm still touching the red graph. So from negative 2 upward, negative, everything greater than or equal to negative 2, I'm touching the red graph. So it's everything from negative 2, whoops, to infinity. That infinity got deflated, didn't it? Okay, we have two more, and they have to do with, I'm going to get this paperweight here to hold the paper down. They have to do with square roots. So that kind of goes back to this idea that I had up at the top of the paper. Will I ever square a negative number? And the answer is yes, possibly, which means that my domain probably, or definitely actually, in this case, will not be something that is negative infinity to infinity. So let's type it. I'm going to move my little blue line here first. And then I'm going to go 4 minus square root, and I'm going to type SQRT, and that just pops up square root. 3 minus x. There it is. Okay. So I wonder what x values I'm using, and I'm actually going to put in a vertical line too. X equals 0. We'll do that. And we can slide that around. So I'm going to slide this little line around, and as I slide it around, I'm going to say, well, when do I touch the graph? Well, I'm touching the graph way yonder back here. And I could even go further. I could go all the way back to infinity if I had eternity to do so. But I don't want to take eternity to explain this problem. So negative infinity up to here. Okay, now the question becomes, first of all, where is here? And I think it's fairly obvious that I'm at x equals 3. And I can see that right here as well. But another question is, do I include x equals 3? Maybe there's an open circle here. What you may want to do on Desmos is kind of click and drag along the function and get to the end of it, and you see a coordinate 3, 4. If it did not exist there, it would say undefined. So it does exist there. So from negative infinity to 3 and not a bit further. So my domain on number 9 is let's go negative infinity to 3, including 3. And then if I wrote that in interval notation, I would say, well, you know what? It's basically everything less than 3, so all my x is less than or equal to 3. My range is a different issue. So I wonder what my range could be. Let's turn this one on. And then we'll kind of slide it around. So down here, am I touching the graph? Actually, yes, I am. And I know you're like, but no, the red and the blue don't cross. Oh, well, you zoom out enough, and they do, okay? And you keep zooming out, and it's going to go all the way down. It takes forever, and it's got a really steep slope to it, but it'll eventually touch, right? So my y values, my outputs are negative infinity all the way up to, boom, right there. And right there is 4. And I can tell that by clicking and dragging that point, and it goes all the way to 3, 4. And we already saw that point earlier, so you probably already knew the answer, but it's going to be every y value that is less than or equal to 4, which means it goes from negative infinity to 4. Okay, last one, which looks like the same problem, but it's got a few other different signs in it, so let's change a couple things. We're going to have a negative, and then this is going to be x minus 3 instead. And so let's turn on the vertical line, the x line. So am I touching the graph? No, 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 yes. And that yes is at x equals 2, and it goes from 2 forward. So my domain is every x value greater than or equal to 2, which means it goes from 2 to infinity. My range is going to be, well, let's see. Let's turn off the vertical, turn on the horizontal, and that crosses my y-axis, which tells me what I need to know. So does it touch down here? Yeah, it does, and even further down it does. So negative infinity up to, boom, right there, and right there is negative 4, y value of negative 4. So negative infinity to negative 4, negative infinity to negative 4, including negative 4. And that means that y is less than or equal to negative 4.